All right, if you've ever been near a construction site, you know the sound, that sharp thwack of a nail gun, driving nails with unbelievable speed. I mean, it's pretty much replaced the hammer. But how it all works can feel like straight up magic. In this explainer, we're going to pull back the curtain on the incredible engineering packed inside this modern tool. So yeah, that's the big question, isn't it? How does this tool take the very real physical act of swinging a hammer and concentrate all of that force into one split-second action? It's not magic, trust me, it's just some brilliant engineering.
To really understand any nail gun, I don't care if it's powered by air, a battery, or even a tiny little explosion, we have to start with the one fundamental principle that they all share.
You know, the secret to the nail gun is actually surprisingly simple. At the heart of every single one of them are really just two key parts. You've got a piston that moves and a long, super tough driver blade that's attached to it. The entire job of the tool is to just slam that piston down, which drives the blade, and then the blade hits the nail. That's it. That's the core mechanism. So the whole firing cycle can be broken down into these three simple steps. First, the gun has to build up some kind of potential energy. Second, that energy gets released, driving the piston and blade forward to fire the nail. And third, the piston has to get back to where it started, ready for the next shot. The real difference between all the nail guns you see on the shelf is how they accomplish that very first crucial step.
So how do they build that energy? Well, this is where the innovation really comes in. Engineers have come up with three main ways to generate the force needed to move that piston, and each one has its own unique pros and cons. On one side, you have the absolute classic, the pneumatic nailer. It uses compressed air from a totally separate compressor, which is fed through a hose. It's super powerful, super reliable, but you're tethered. And on the other side, you've got the combustion nailer, a completely portable solution that makes its own power using flammable gas. Okay, this is wild. The combustion process is basically a tiny single-piston car engine in your hand. A little bit of flammable gas gets injected into a chamber, a fan mixes it up with air, and then a spark plug ignites it. That small, controlled explosion is what drives the piston down with incredible force. It's pure internal combustion, just miniaturized. But what if you don't want to mess with a compressor hose or deal with gas cartridges? Well, that's where electric nailers come in, and they use two very different and very clever methods. One uses the stored-up energy of a spinning flywheel, while the other uses the power of an electromagnet, which is called a solenoid. This quote from DeWalt explains the flywheel system just perfectly. When you pull the trigger, a motor spins up this heavy flywheel to a really high speed. Then, a mechanism literally engages the driver blade with that spinning mass. All of that rotational energy is instantly transferred into forward motion, shooting the blade forward. It's a really ingenious way to turn electricity into a powerful, instantaneous punch. Okay, so now we know how they work, but knowing the mechanics is really only half the battle. The next, and probably the most common point of confusion for anyone looking to buy or use one of these, is figuring out which nailer you actually need. And this is the perfect example of that confusion. The word framing means two totally different things in construction and in crafts. Using a framing nailer, which drives these huge 3-inch nails on a picture frame it would just obliterate it. And a little brad nailer meant for picture frames would be completely useless for building a wall. So the key thing to understand is nail gauge. It's a little counterintuitive, but the higher the gauge number, the thinner the nail. A framing nailer uses thick, low-gauge nails for serious structural work. Then you have finish nailers for things like trim and baseboards. A brad nailer is for more delicate work. And finally, a pin nailer shoots these tiny, headless, 23-gauge pins that leave an almost invisible hole, perfect for tacking little pieces of molding in place. Now that we've got the power sources and the different types of nailers down, we have to talk about the most important part of the whole equation: you, the operator, and the safety features that are supposed to put you in control. Take a look at this number, 42,000. What do you think that represents? It's not the number of nails in a box, I can tell you that. That's the estimated number of ER visits from nail gun injuries in the US every single year. It's a staggering figure, and it proves these are powerful tools, not toys. Understanding how they fire is the #1 way you can stay safe. Most nailers give you two ways to fire, and it really comes down to a trade-off. You've got sequential firing, which is all about precision and safety, and then you have bump firing, which is designed for pure speed. So let's look at sequential firing. It's called sequential because you have to do things in a very specific order. First, you press the safety tip on the nose of the gun against whatever you're nailing. Only then can you pull the trigger to fire one single nail. If you want to fire another one, you have to lift the gun, let go of the trigger, and start that whole sequence over again. It's deliberate and it's precise. Bump firing, on the other hand, just flips that logic on its head for speed. Here, you can hold the trigger down the whole time. The gun will then fire a nail every single time that safety tip gets pressed or bumped against a surface. This is for those high-volume jobs like roofing or flooring, where you're moving fast across a big, flat surface.
So there you have it. Whether it's harnessing the power of compressed air, creating a tiny controlled explosion, or converting electricity through a spinning flywheel, the nail gun is a true marvel of engineering. It is so much more than just a faster hammer. The only question left is, which of these incredible solutions is the right one for what you need to build?